Hello everyone, today we're going to do a composition of function for pre-FE pre-calc class. Let's start with the Bellwork. Alright, so it looks like the first three problems refer to this graph on your right, the g of x. Number one, which of the following is a true statement for the multiple choice? Well, here's what I'm doing. You can pause the video, folks. I recommend you do the four problems first and then resume back, because what's the point of me going over that if you haven't tried it yet, right? All right, so just pause it and come back. Okay, so let's go. The graph of f of x is constant, and then we're talking about increasing and decreasing, so let's review it. When you are finding such the x values, you're always going to want to go from left to right, right? So constant is the same slope. I see a constant over here from -5 to -1. So just looking at it, it looks wrong, so I'm going to cross that out. So which one has 1? That. So really, we just got left with B or C. Number 2 only or number 3 only? That's the tip of the multiple choices. Get rid of the ones that contains the wrong answer in, right? All right. G of x is decreasing, so going down from left to right. So it has to go down this way. I see over here, left to right, in decreasing, -1 through 2, okay, and over here as well, 4 to 6. Notice it's all the parentheses. That's good, because for the end points we don't include them, so that is correct. So really, I'm not even going to check the 3, because that's the only answer I can have, right? Okay, very good. Number 2, which of the following keeps flicking? Which of the following interval include all of the value for which g of x is less than or equal to 0? How do I find that, folks? This is y is less than or equal to 0. Right? What does that in terms of the graph? That is below or on the x-axis. Below or on the x-axis. I'm going to use my highlighter. Below x-axis. For me, it looks like just those points right there. What about those points that are on the x-axis? Since there's an equal to it, you have to include it. So it's going to look something like this. 1, 3 with the parentheses around. Let me see this one. All right, 1, 3 and 5, 6 with the bracket and bracket, since you have to include both of them. Pretty easy. All right, so if f of x is that, what's the value of this? What does this mean? We kind of went over that last class, folks. This is the same as f of -1 plus g of -1. So add two functions when both inputs are -1. Well, where is f? Where's the function f? Right here. Right? So what is f of -1? You plug -1 inside of the x. Notice I put the parentheses around -1 to protect it. Remember that? So 2 minus 1 minus 2 is -1. That is -1. What about g of -1? Where is the function g? That's the graph over here. When x value is -1, y value is 4. So -1 plus 4, 3. Cool. All right, the last problem. What is the domain of that? So that's a review of the actually Tuesday's lesson. It's the function. Okay, so there are two functions with the real domain going on, right? So let's review it. What are those two? There's a rational function. There is a square root function. How do you find the domain of those? For rational function, your denominator cannot be equal to 0. I hope you remember my math commandment. Thou shalt not divide by 0. And square root, the radicand. What is a radicand? Whatever inside of the radical has to be greater than or equal to 0. Okay, those are two special cases that we have to find of the domain. The rest, like linear, quadratic, all has a domain of -infinity to +infinity. All right, so look at this function. I see a cube root, but I also see a rational. The x is in the denominator, so it's a two special function combined together. What is the domain of the cube root function? It's everything, so I don't really have to worry about the cube root, but the fact that it's a rational function, my denominator can't be equal to 0. My denominator can't be equal to 0. Add 2x to both sides. X can't be equal to 5/2, which is 2.5. So x can't be 2.5, but it can be everything else. So what would that look like in interval notation? Letter T. Okay, all right, so that's a Bellwork. Cool.